Hey folks, welcome to another Sverchok tutorial. This one is kindly sponsored by SkillShare. More on them later on. In this tutorial we're going to be having a look at making mushrooms, and specifically we're going to be going through the process of doing a Bridal Veil Stinkhorn, which are these ridiculous looking mushrooms with the skirt. Very cool. So there's a nice way for us to make these in Sverchok. This is quite a good example. So we're going to be making the stem and the cap and the skirt as kind of separate objects, but they're all going to be driven off the same few curves. And we're going to be doing it this way because I want to have curve control in the 3D viewport. I want to be able to move stuff around as I want, in 3D. And then obviously you can like move handles. It's just it's a little bit of an easier way of working with procedural systems. I'm in Blender, I'm using 3.0, and we'll be jumping up into Sverchok here. So I have a large node tree, small 3D. If you followed through before, then you know what we're doing here. So we're going to make a new node tree, call this one Mushrooms. And in the outliner, I need a few things. So I need a new collection called Input Curves, just to keep things neat. And I'm going to make another new collection, and I'm going to call this one SV Output. Just so I have, separate stuff in separate places. Always a nice way to work. Make sure you stay on top of housekeeping. Okay, in the 3D viewport, let's go ahead and add a curve circle. And right now this is enormous. You gotta remember that a mushroom is teeny tiny. So we're going to be trying to work at an approximately real dimension here. 0.02 is probably fine for the bottom of the stem here. Let's go ahead and apply rotation and scale. I probably also want to change my camera clipping if I'm working this small, because I have clip start at a centimeter. So let's just turn this down to a millimeter instead. It's going to save us some headaches, and I kind of want to, oh, there we go. So if we set our grid scale down to 0.01, there we go. Now we actually have a grid that we can work on. Looks a little bit more familiar here. Okay, so let's grab our Bezier circle. This one's the base of the stem, and I'm going to duplicate this one up a little bit. Let's just go into side view here, make it bigger. This is the base of the skirt. I'm going to have one for the middle of the skirt just to have a little bit more shape, and then we're going to have the bottom of the cap itself. Something like this. And just for making sure things are going to work out, I'm going to initially put them really off, kind of jaunty angles like this, just so that we have a little bit of shape in the beginning. Sometimes when you're making stuff and you're doing it for beginners, exactly on the 0, point, and then also if you're doing it in a straight line, and you're thinking like, oh yeah, I'm making all of this curvy stuff, and then I'm just going to curve it later, and then you build your system and then it doesn't work. So it can be nice just to make sure that things are going to work from the beginning by putting everything kind of in a position which is going to challenge it. Okay, we want to get curves into Sverchok, and we're going to use a node called the Bezier in. These are Bezier circles, so we're going to use the scene Bezier in node. I have snapping turned on, which is why things snap to my grid. Okay, get selection here. Now what we're interested in, let me just double check that everything has a rotation. Good. You don't want to zero out your rotation. You want this to be correct, but we do want to zero out our scale here. So I'm going to apply scale. There we go. Apply scale. So everything is a 1 in the scale, but it still has its rotation values. That's good. Awesome. So after this point, I'm just going to be moving stuff with moving the points. So sort of general transforms we can move around, but size and actual shape we'll do with the points. Just keeps things a little bit more sensible. Right, let's start with the stem. And I'm going to show you a cool way of working here. Let's go ahead and use our curves evaluate curve node. I recommend putting this onto your quick favorites. So I've got evaluate curve and evaluate surface just because they're at the bottom of their lists. It's a bit of a pain. So evaluate curve. So we can see we have all of our curves. I only want the bottom one. So I'm going to grab a list structure list item. This is going to error saying that there's no data at level. Well, saying there's no data. So let's change this to level 1. And now we can see that we have a picker for our items. We're interested in the base one, so let's just leave this as 0. And this is the curve that we're going to be using for our positions. I'm going to also just grab it and scale it down. I'm doing this in edit mode now just because I don't want to mess things up. So I'm going to do something like this, and I'm also going to make sure that my large one here, so the base of the cap is a little bit bigger. There we go. You can change frame or update on the node to get that update into Sverchok. Cool, so what I'm going to do is I want my stem to be nice and curved. So rather than just positioning another circle up here and drawing straight lines in between, we're going to have a little bit more fun, have a little bit more control, and make sure that we get some nice like plump looking toadstool base. Let's first of all grab a central point. What I'm going to do is I'm going to find halfway in the Z between these two, it's around about here, and I'm just going to put this directly above the base. So we're going to have a point in the middle, point at the base, and then at the sort of the center of that top one, and then we can just draw a spline in between them. This is going to work for our stem, and it's just going to give it a little bit more sort of control, and even at quite intense angles, you're going to have quite a lot of fun with positioning and doing sort of characterization of your assets. Right, so what we need is a few more things. We're going to need another one of these list items, but this one is actually coming off the matrices. So the data comes in here. Let's have a look at this. So we have our ground one, this is the base, and we're going to do one more here, which is going to be our top. So there we go, number 3. What I want to do now is just find halfway in between these. So I'm going to use a matrix interpolation, there it is. So items in here and here. And now you can see that we have a nice slide to go in between them. Let's set this to 0.5 so that we have halfway. And I'm then going to use vector out. And I just want to find the Z. So I've got 0.02 there, which is approximately correct for what we want. And this is going to be the height of a line that we position on the base matrix. Okay, hopefully this is not losing anyone just yet. Let's grab a generator line. So we're going to generate a line in here, which we can see. I'm going to position this on this matrix, which is the bottom there. So we're going to use a transform matrix apply verts. This goes in here, matrix from the bottom goes into the matrix. There we go. And you're not going to notice this change because the bottom isn't in a different position. But if I was to play the timeline and then move this, then you can see that that does actually move around, it sticks to it. We're going to go in the Z direction because we're interested in the height. And the length of this line is going to be the Z from our matrix interpolation, which is like the Z position, right? So take this into our size, and you can see that we now have a line nicely tracking up from that bottom, looking pretty good. I'm not actually interested in the edge, we only want these vertices, and then I also want the vertex from the top one, which is here. So for this, we're going to need to join these into a list. So we're going to use a list join first of all, and then we're going to use a matrix out so that I can take this. I know we just plugged the matrix into the vector before and that worked fine, but because the list join isn't like specifically doing implicit conversion on vectors, it's just a general data in, we're going to need the matrix out to actually convert this. So we can take the location into here. There we go. Now we can see we have 3 points. Awesome. Let's have a look at this data. We're going to use a text viewer text mark 3. I've got it set to auto update and frame here. Drop it in here, and we can see we have 2 objects. We have the base and then the middle, and then in another object we have the top. So let's change our join list levels to level 2, and let's join those up nicely. All right, we have a list of vertices in a curve. Let's make them into a real curve. We're going to use a curve cubic spline. This is just going to allow us to turn a list of vertices into a spline. We can then use an evaluate curve to have a look at this. There we go, it looks pretty correct. That's what we want. So if I was to move around this top piece, you can see what's going on there. We can actually get some nice rotation. Looking good. Now, what do we want to do? We want to take our base circle, this one, and we want to position it on a bunch of locations sampled off our spline. So let's go ahead and use you can probably just use the curve frame for this, and this is going to allow us to basically calculate a bunch of matrices along this curve. So that's pretty good so far. We can also, instead of using just a single value for t here, we can use a number range, which is under our number range. Set this to count. Our curve domain by default here is going to be 0 to 1. So we can set our start and stop for it to 0 and 1. And then the count is just the number of matrices we're going to be generating. Now, if you want to move a curve, a little bit confusing here, you're going to use the apply field to curve. So there's no like transform curve node, at least there's no node that's called transform curve, but we can use an apply field to curve with a matrix. And what this does is it basically reads the matrix as a constant field. Just plug your matrices into it and you'll get a bunch of curves. So that's looking pretty good so far. So now we have all of our count. We can change the count depending on how many times we want to create these curves. And this is looking nice, but I want to do a couple more things just to make sure that we have some additional shape and positioning. So let's start off with the shape here. We're going to use a matrix deform node. So matrix deform. I'm going to drop this onto this. And now what we can do is if we plug a number node into the scale, then you can see that we can actually affect the scale specifically. So what this means is if we plug our number range, which has, you know, a bunch of data and it all lines up, it all meshes correctly because we have 14 values coming in here, 14 matrices. If I plug this into the scale, you can see what's going on here. We get one value per matrix. We want a little bit more control. Let's use a number curve mapper. Very fun node to work with. And if we want this to just update live, then we need to play on the timeline. You can see that we can change the shape. So what I'm going to do here is I'm going to come a little bit wider at the bottom and then real wide, like real bulbous looking. And then we're going to come in a bit. Make sure we have this kind of cute little mushroom stem look going on. Isn't that nice? Okay. And after we've got our curves, we're going to want to turn this into a surface. So let's go ahead and just use a surface. Surface from curves. Plug in our curves, use an evaluate surface node, and view the output. What more could we wish for? You can set it to cubic if you want a little bit more smoothness. Although at this kind of sampling, it's probably not going to have a huge impact, but it does mean that you can use fewer if you would prefer to. All right, we need to tweak a few things. So if this is the top of our cap here, we want this stem to actually push up a little bit further. We don't want this to stop dead on that line. A nice easy way for us to do this is to take this matrix, which is our top position, and we're going to move it up in the local matrix direction. So to do this, we're going to need a matrix math node. Just going to plug this on here, and then we're going to use a matrix in node, plug this on, and use a location in the Z. So you can see that this is actually going up in the local Z. If I set this to post instead, then it's going in the global Z, pre is in the local. So this is why we're using matrix multiply instead of matrix deform, because this needs to be sort of after the other one happens. Okay, we don't need to go too high, we just need to hide it a tiny little bit. 0.005, there we go, 5 mil. Looking good. This is one cute mushroom. Let's get the top going. First of all, let's talk about SkillShare. SkillShare is an online learning community with literally thousands of classes in a whole range of topics, from things like film and video, leadership and management, illustration, music. So we have all of our creative side, and then we'll have all of our business side. And this is just going to help you get really embedded into, you know, life as a creative and potentially as a professional creative. One of the courses that I've been getting into recently is Always Drawing by Mike Lowry. This is a great course. So it's all about getting started with sketchbooking and trying to keep a daily sketchbook. And something that I guess I don't really talk about now, since doing YouTube and Blender and everything, is that I kept, I should say, loads of these sketchbooks, right? I just grabbed a couple of handfuls off my shelf. You can see there's more behind me, but I kind of fell out of the habit of doing these. And I've been wanting to get back into drawing for a long time, because drawing used to be a really big part of my identity and just kind of how I spent time creating stuff and expressing myself, and sort of being able to like understand and maintain prescience about my environment and the places that I was in. So to take this has actually been great. It breaks sketchbooking right down into exercises that you can do, but also at the beginning explaining like what is a sketchbook, what can it be and what can it become for you. And he even covers just getting over that initial sort of hump with starting a new sketchbook and the kinds of things that you can maybe think about going into when you create your own sketchbook. And one of the things which I really like about taking classes like this on Skillshare is that there's no disruption, there's no adverts, there's nothing that takes you away from the learning. Once you're in it, you can just stay in it the whole time. The first 1,000 of my subscribers will have access to Skillshare Premium for 1 month, so you can start exploring your creativity today. Alrighty then, let's get back into Sverchok. First of all, we are going to frame all of these up because organization is key. So Control J, grab this F2, let's rename this one to stem. And we're also just going to save our file, make sure you're saving. And the next thing we're going to be doing here is grabbing the cap. So it's a similar process, but instead of taking 2 points, we're just going to do it in a straight line out of the top. So let's just basically do the same again. We're going to be using a list item, grabbing our curve number 3. So let's use evaluate curve on our item. View this, make sure that our list item is set to level 1. Pick the curve that you're after, which in this case is the top. And we're also going to be pushing this along a matrix. So I've just duplicated that list input. Have a look at our matrix here. Here we go. And that is our top matrix as well. So this is important because we actually need to remove this matrix. It's to ensure that we have the 3D controls that line up to everything, but we're still positioning this on a specified matrix, even though we've already applied the matrices to it. I just find this easier to do it this way, where we remove one matrix rather than do it the other way, which would be to turn off apply matrices and manually apply 3 matrices instead. So in this case, we're going to be taking our top matrix and we're going to put a line on it, just a curve line actually. So we're going to be using a curve line here, plug this onto our 0.1. Is that right? Did I do that right? Curve. Sure. And the direction is going to be, oh no, I didn't. Okay, so we're going to go from 0.1, which is 0, to Z position. We're going to make sure that we're leaving our U min and U max, right? Because this is our curve domain. And I want this to be 0 to 1, so that we can still have this fun stuff with the curve mapper without needing to do any additional maths. So I'm going to go up slightly here. We're only going to go up a little bit, 0.02 or something in the Z. Looking good. So now we just need to position this curve on this matrix. We do this with our apply field to curve. So curves, apply field to curve, join this in like this. And now you can see that we have this on our curve. If I move that around, it sticks. Nice. So now we just want to actually sample some frames off here, get some frames off these curves. So let's go ahead and use a curve frame. Here we go. And oh, this says 0 curvature, so it's impossible to calculate. All right. Well, in that case, perhaps we'll get away with using a 0 twist frame, or we might just have to make this subtly curved. Let's try this one. And again, this one's going to fail. Oh no, this one seems to be doing it fine. Track normal, doing the top job. Here we go. So 0 to 1, doing a great job. Awesome. So curve 0 twist frame, track normal, good to go. Let's go ahead and use a number range. Set this to count, 0 to 1, because that's the domain, and we can plug this into T. Now we can see we have a bunch of circles. What we now need to do is take our circle from the top, which is this cheeky chap over here, and position this on all of these matrices, right? So if I just do that like this using the temporal viewer, then we can see that we have this massive offset. So what we actually need to do is we need to also remove this original matrix from them. So let's go ahead and do that. So we're going to take our curve here just before we evaluate it. And we're going to do another apply field to curve. We're going to plug this into our curve. We need a field, which is going to be our matrix. And there you go. You can see that's doubled up. But what instead we're going to do is we're actually going to invert this matrix with a matrix math node. Drop this on here, set this to invert. And there we go. So we zeroed that out. Nice. And now we just need to use another matrix math node to multiply these together like so. If I set that to post, that seems to be doing a top job. Let's play the timeline and see if we can actually get these to hold on. Seem to be working a-okay. So always good to just stress test things as you go in. Nice. So we have our positions done. Let's deform this with our scale as well. Where are we putting this? Just after the 0 twist. Let's go ahead and use a matrix deform. Make sure this is going to work by plugging our number range into the scale. Good, that looks correct. So now we can just take a number curve mapper node, plug this on here, play the timeline so that we can see what's going on. And we can just go ahead and increase this and decrease this a little bit, give it a little bit of shape. Something like this is probably going to look pretty good. And then we can just go ahead and skin this. So we're going to stick on a surface from curves node, delete the evaluate curve, grab a surface node, surface from curves, curves go in, evaluate surface node. Good. Now we have a couple holes, probably going to just pinch that like that. And then I might also set that to cubic on the surface from curves. And then we're just going to go ahead and merge doubles. Merge by distance, there we go. If I select these three and I just hit V, then it's going to plug them up left to right. Ooh, we're getting some cool effects here. Maybe if we turn this up, it'll look better. We've got to work with some small values in here. Something like that, maybe. Maybe a bit bigger. Maybe if I just turn up the samples instead, this will look better. That does look cool. Okay, the reason I'm doing this is because the Stinkhorn has a pretty lumpy top. And I guess a nice, easy way for us to get some kind of pretend version of this is just to do this and then use like an inset special, because that's nice and fast. Jump this on, select these three, hit V, there we go. So if we reduce or increase the inset with this set to distance, and then we can set the distance there is having a bit of a hard time. We want to go 0.002, that's definitely too much. 0.0005 looks beautiful. All right, so this is our cap kind of thing. We'll just push out some meshes now, just while we're still working on this. So let's get rid of that temporal viewer, join these two up with V. Make sure we're renaming this to cap to begin with, and we're going to be putting it in the SV output collection. There we go. Select these, Control J. I'm going to call this one cap. And let's go and put a mesh viewer after our evaluate surface down below as well. Viz mesh viewer, drop this into this collection as well. Join these up with V, and we can call this one stem and pass this into our SV output collection. If you want smooth shading on either of these, press N, go to node, properties, smooth shade with your mesh viewer selected. You can do the same up here. Smooth shade looks great. Looks like a really hideous lampshade. If I just want to be able to move the controls without moving these objects, then you can always just turn off the actual clickability of these, and then you're guaranteed to touch the right things. One more thing to do is actually make the skirt itself. This one's a fun one. Very simple as well. So we're just going to a list item node. We're just grabbing curves this time. Let's have a look at what we're grabbing. View this. Nesting level is wrong, so let's grab level 1 on the list item, and we can click through here and see what we have. We want to select multiple items, so we're going to use a number list input node. Set this to 3 because we want 3 curves. Plug this in. I want curve 1, 2, and 3, so I'm going to write this as 1, 2, 3 with these being integers, and you can see that we just selected those 3. Now I want to loft a surface over there, so we know what we're doing now. Let's grab a surface from curves, drop this on here, can delete the evaluate curves, get an evaluate surface, view this. Let's change this to cubic to make it a little bit more smooth. And then what we can do is, I don't know what the accurate way of doing this would be, probably Voronoi. But Voronoi, so you could do it with Voronoi, with one of these spatial nodes. If you have, oh, do you know what? We have surface and we have Voronoi on surface. So I was thinking that these rely on additional dependencies. So if you don't see these, then in your Sverchok settings, up in here, you can jump into extra nodes and you can just go through like pip is available, upgrade pip, give it a few moments to download and install, and then just go through like SciPy, GeoMDL, and this one's just going to give you some additional curve stuff. If it fails, then you may need to give Blender admin privileges, but if it doesn't fail, it'll say this at the bottom, like upgraded successfully, restart Blender. I'm just going to go with the default things that we can find in here, because I don't have any of those dependencies on this install at the moment. So let's go ahead and populate surface, just because we have a surface. This is one of the joys of working with surfaces instead of meshes. Do all of your sampling afterwards. So we've got our spatial nodes here. So populate surface and a Voronoi on surface. We just plug our surface through, plug in our UV points, give this a few minutes to update. It was only about 20 seconds actually. Let's have a look at what's coming out here. It says empty vertex list. Oh, we have a minimum distance and threshold on here. If I turn on my node timings, you can see how long this is taking 5.5 seconds to calculate that. Let's set the minimum distance to 0. And there we go, 6 milliseconds, and it's not going crazy. Good stuff. And now our Voronoi on surface is actually displaying something, so that's nice as well. Now we can see that we are getting this issue down the back here. It's a bit of a shame it's not really joining stuff together. Let's just increase our count a little bit more. So we have a whole bunch of these. I wonder if I should reparameterize my surface so that they have more, because we're definitely shorter than we are long in terms of this surface. So let's go ahead and just, oh, there we go. So we have a surface node here, reparameterizing from, okay, so I see what I'm doing. I'm outputting a bunch of points in the UV space, right, for 0 to 1. And what we should probably be doing is, if I was to reparameterize this surface, and the issue is that as soon as I use this reparameterized surface, oh, I see, it's like wrapped it. That's weird. So why is this? Interesting. So what I think is happening is that the reparameterized surface is actually wrapping this a level down. I can see that in the data. If we use we're going to turn on socket menus. So turn this on and we're just going to unwrap this. And there we go. Now we have a bunch of points. We're going to be using the reparameterized surface, but we're going to unwrap it. So just on this menu, unwrap. So let's go ahead, use our populate surface for an ion surface. I can now view this and make sure that I am doing a new U2. That's giving me a bit better. So let's go up to 3. A little bit better again. Let me plug this in. Oh no, that's definitely worse. Make sure you're plugging from your reparameterized surface into your Voronoi as well. So we're going to go, 1 in the U and 3 in the V. Oh yeah, that's loads better. How strange. Okay, so just make sure you're doing the unwrap thing. All good. All's well that ends well. Let's have a look at the make faces option here. So this is going to allow us to make faces. I would really like to use the boundary loops as well, but doesn't seem to be doing that. We can maybe make a few more here. Let's go up to 600, maybe even higher. And I can increase the size just to make sure that we have all of the holes filled. And then let's go ahead and use a inset special again. Here we go, inset special. This one's real fast, so this is why I like it. Join it up with V, get rid of those edges. Setting, oh, sorry, not the distance. We're just going to be changing the inset until that looks right. And then we're going to take our make inner option at the bottom, set this to 0. And now we've just got our sort of Voronoi grid kind of looking thing. Okay. One thing you may want to do is just move your top, basically apply a new matrix to it just to shuffle it in a little bit if that's something that you wanted. But in this case, I'm just going to leave it. I know it looks like it's not quite hanging on, but I'll take it. Okay, mesh viewer time, viz, mesh viewer, join these up with V. Make sure we're passing this out to a proper name. We're going to call this one skirt, and we're going to drop this into the SV outputs folder. And we're going to make sure we're using smooth shading on the node tab here, smooth shade. And let's also just give this, let's select it, give it a solidify modifier and set that to something appropriate like 0.001. Maybe change your inset values. You could even do more stuff like adding a subdivide and a displace modifier before the solidify. So what this is going to do is it's going to allow you to break up your edges. Let's go ahead and do this. So subdivide surface. Let's make these a little bit more rounded. And then we can use a displace modifier, right? Set new, go in here, clouds. It's probably what we want. And we want this to be a very small thing. I mean, that's kind of gorgeous actually, but just not what we want. So let's set this down to like 0.01. We could maybe even go a little bit less, 0.005, just to get real bitty. And we're going to set the strength to 0.01. I want this to really break up the surface here. I would love it if I could get it to go in tangent space only instead of normals, but we'll go RGB to XYZ, change this to color, and reduce that strength down even further, 0.02 or something. Just make it a bit wobbly, you know, make it a bit more soft. And then let's chuck our our solidify afterwards with a little bit more thinness on there, something like that. Okay, I know I have this opening at the back, but I'm just gonna fix this by not looking at it. Let's put all of these into a frame. That was actually quite a short bit. Rename this one to skirt. And now we've got ourselves a mushroom. So we can add a plane, scale this up, have a look at this in rendered view. Here we go. I want to have some like little magical lights going around, so I'm just going to add a circle generator in here, and I'm going to make it real small, come in something like this, and I'm going to use these as light positions with a light viewer. Here we go, light viewer. These are our origins. We're just passing through some little lights here. Strength of definitely not 100. point to something like that. Isn't that spooky looking? Awesome. All right. So you can still do all of your things. Let me just make sure I can't click on that skirt. So yeah, if I grab one of these edges, right, and I can let's have a little bit of fun tweaking stuff around, maybe make some shapes in here, maybe make this top one a little bit less. I'm doing all of this shaping in edit mode from this point. Oh, we can see this is actually flipped around. We could always fix that with a little bit of matrix multiplication. Grab this bottom one as well. Let's pull this down a little bit on each side, maybe do something like that. Okay, so the reason that I love doing stuff procedurally is because of art direction, right? You get to really control your shapes, and it makes it a breeze. It's kind of like rigging, I guess, but you get so much easy control. So I know that we've just made this mushroom, which is somewhat simple really, but there's so many ways that you could use this in terms of like built environment. I mean, imagine if you were like building some sort of avatar-esque worlds with giant mushrooms in them, right? You could have so much fun with this. There you go. That's how we can use simple curves and surfaces and Sverchok to make a little Bridal Veil Stinkhorn mushroom. Hope this has been fun and informative, and I'll catch you in the next one.